over the last 2 to 3 decades, fossil-based materials, also known as synthetic fibers, have become really the dominant material in the textile sector. Now, today, we're using about 2/3 of the materials that we use in the industry are fossil-based, and only 1/3 are natural or bio-based fibers. We use a lot of synthetic fibers in clothing and fashion and home textiles, but we use them even more so in the technical applications, of which there are many in textiles, including, of course, also composites. So why do we use so many of these synthetic fibers in those technical markets? Well, because they have 2 very big advantages. They have performance advantages. They're very resistant, they're very strong, they're very abrasive or abrasion resistant, and they also have an economic advantage that they're very cheap. So because synthetic fibers are made in petrochemical processes, in huge processing equipment, economies of scale, so they become very cheap. That's a big advantage over natural fibers, which do not benefit from the same economies of scale. So, but there's a problem related to this, and the problem is that these fossil-based materials are contributing over the long term both to carbon emissions, because often at the end of their lives they may get incinerated and turned into CO2 in the air, or they pollute the environment in the form of non-biodegradable waste, often also then degrading into microplastics and so on. So for this reason, there's a lot of effort being made to replace those fossil-based materials by non-fossil and renewable materials. And we can do that in several ways. We can use, of course, recycled materials, so we can recycle those fossil-based materials back into fossil-based materials or back into synthetic materials without first turning them into CO2 in the air. But secondly, we can also use biomass to generate the carbon, the materials that we need for the textile sector. And Waste to Biocomp has basically tried to do both. So using waste, also using bio-based waste, of which we have a lot also from agriculture, from food production and so on and so forth, to turn them into textile fibers that then are renewable. They are not contributing to extraction of fossil resources, and that in the end are also not contributing to CO2 emissions or less CO2 emissions in the air. So all of that is, of course, in a research state. So there are a lot of things that we need to understand about those materials. Economics have to be improved a lot for them to be competitive with the conventional fossil-based materials. But this is the kind of work that we have to do. We have to understand what technically really works before we then can improve the economics, and then hopefully have, over the next 10, 20 years, new materials for the textile sector, whether for technical or conventional applications, that can replace gradually the fossil-based materials that we use a lot. And this is something that Waste to Biocomp has really tried to do over its duration, and I think they're very interesting results, and we then have to build on those results to make those new fiber types or those new processes of making fiber really economically viable and scale up.